Hi guys, this time I'm gonna talk about Graham's law. It's a law that tells us how fast a gas moves around a medium. For example, this is the equation that we're gonna use. It's telling you that we have a rate of diffusion of gas A over the rate of diffusion gas B. This is equal to the molar masses of B divided by molar mass A. Now, I want you to have this in mind. The gases that have less mass will spread faster. So, when your mass is a small mass, the velocity will be faster. Now let's take a look. This sample problem says compares the rates of diffusion of hydrogen and oxygen. Okay, they are both at same temperature and pressure. So we're going to compare both gases. Hydrogen and oxygen, if you remember, both are diatomic. Okay, that means that one molecule of hydrogen has two atoms. So the molar mass is 2 times 1.0079 grams. This is equal to 2.0158 grams. Now what happens with oxygen? It's also diatomic, so we're going to multiply 2 times 15.999. You can write 16, it's okay. That's the way I do it. Using 16 instead of all these numbers. So this will give you 31.998 grams. Now let's take a look. I will compare both of them. So I'm choosing, for this exercise, I am choosing my gas A will be hydrogen and my gas B will be oxygen. Now let's see. If I want to know the rate of diffusion of hydrogen, will be rate of hydrogen divided by rate of oxygen. This will be equal to the square root of, now take a look here, the one in the top is the one that will have the molar mass below, and the one below is going to have the molar mass in the top. So here I'm going to write oxygen, that is 31.998 grams, and below I will write a molar mass of hydrogen, that is 2.0158 grams. Now take a look here. As I have grams and grams, both are going to be cancelled. Now let's see. 31.998 divided by 2.0158, and then I get the square root of my answer. I have 3.98. So take a look. If I want to know what is my rate of hydrogen, my rate of diffusion of hydrogen is equal to 980 or 98 times the rate of diffusion of oxygen. What does it mean? That hydrogen moves 3.98. This is, we can round it to 4 if you want. Okay, moves 3.98 faster than oxygen. And voila, that's it. Okay, let's see another sample problem of Graham's. Neon gas travels at 350 meters over second at a given temperature. Calculate velocity of propane, which is C3H8, at the same temperature. So if you see all these exercises, compare two gases or more than two. You'll see one exercise using more than two gases, but they sharing conditions like temperature or pressure in the example before. So in this exercise, I am comparing neon and propane. Now, you have to get the molar masses of both. So neon, its molar mass is, let me see in the periodic table. Okay, neon is 20.1797 and propane will be 3 carbons plus 8 hydrogens. I'm gonna do this quickly, so I'm gonna have 3 times 12, 36 grams plus 8 times 1, 8 grams of hydrogen. This will give me 44 grams. I just want to work quickly. Now, if I use the equation again, Graham's, I will have my rate of diffusion of A against B. Now, take a look. I wonder, in this exercise, I want to know my velocity of propane. I know velocity of neon, that is 350 meters over second, and I want to know the velocity of C3H8. Okay, so as my unknown is propane, I'm going to write it in the top. In this case, propane will be E because it's my unknown, and neon will be B. Take a look. So I have my rate of diffusion, rate of C3H8 divided by the rate of neon. Now, remember that we switch the masses, the position of the masses. My neon is going to be in the top, 20.1797 grams, and my propane will be below. I cancel my grams and grams, and I perform the calculations. Okay, I have the square root of 0.4586 and a lot of numbers. When you get the square root, you'll get to be 0.68. I round it, okay? Now, to know the rate of propane, I will isolate. So my neon rate will go to the other side to multiply. Here it is dividing, comes to the other side to multiply. So my rate of propane is going to be equal to 0.68. Now, neon was divided, come to this side to multiply. Now, this is my rate. But I don't wonder what about my rate. Okay, I need to know the velocity of propane. So I say, step number 2, velocity of propane. So I know that its rate is 0.68 of neon. That means that propane is traveling only 68% of neon's velocity. So what I do is I would just multiply times neon's velocity, which is 350 meters per second. 0.68 times 350 gives me velocity of propane equals 238 meters over second. Now remember, a way to check if you did it right is visualizing that the gas with the least mass has a greater velocity. Take a look. Neon's mass is 20, is less than propane's mass, which is 44. And if you compare, neon travels at 350 because it has less mass, and propane travels at 238 meters over second because it's more massive. So when a gas is more massive, the velocity will be slower. Now let's take a look at this example. Hydrogen sulfide, H2S, has a very strong rotting egg odor. Methyl salicylate, C8H8O3, has a wintergreen odor, and benzaldehyde, C7H6O, has a pleasant almond odor. If the vapors of these three substances were released at the same time from across a room, which odor would you smell first? Okay, imagine that I have in a room, in the same position, that I have those three gases here. Let's say this is hydrogen sulfide, let's say this is methyl salicylate, and this is benzaldehyde. Let's just think that it's like that. Now, if I open, imagine those are bottles containing gases. If I open them at the same time, in the same space, in a room, and I am located right here, for example. I am located right there. So, if I open those bottles containing gases at the same time, which one is going to reach, which odor is going to reach to my nose faster? Imagine this is a race, and the one that has less mass is the one that will arrive first. So for solving this problem, we need to compare the masses. Take a look. As we said before, we're gonna compare the masses of the three gases. So my first gas is hydrogen sulfide. I have 2 hydrogens and 1 sulfur, which the mass is 32 rounded. So the total mass of hydrogen sulfide is 34. Let's go to methyl salicylate. You have 8 carbons plus 8 hydrogens plus 3 oxygens, a total mass of 152 grams. And then you have benzaldehyde, 7 carbons, 6 hydrogens, and 1 oxygen. You add them all and you have 106 grams. So, just by taking a look of the masses, I notice that hydrogen sulfide is the least of the masses. That means that hydrogen sulfide is going to be the fastest. Okay, this is the fastest. Now, between 152 and 106, this stays in the middle, and this is the slowest of the gases. Okay, now that's it. it says, which odor would you smell first? Obviously, because I already compared my masses, I know that my hydrogen sulfide is the fastest of the gases, so this one is going to be my the first smell. So my answer is I will smell first hydrogen sulfide, but that's the gas. I want to know the odor, okay, because it says which odor. Now it says that it has a strong rotten egg odor. So which odor I will smell first? It's rotten egg odor. That's how I answer the question. That's everything they're asking me. If you see, I didn't use Graham's law, the equation. No, I just used the analysis that we did before. Now, but what happens, because you know Miss Martinez, what happens if I add this to the problem that says, if hydrogen sulfide travels at 320 meters over second, calculate the velocity of the other gases. Now, what I should do is, I know what my fastest gas is. I know that it's hydrogen sulfide. So, to answer this question, now I will use my formula, Graham's law. So I say, okay, let's take a look. Here I have my two other gases, methyl salicylate and benzaldehyde. So I will compare against which gas? Against the given, which is hydrogen sulfide, because I know its velocity. So I say my rate of methyl salicylate against the rate of hydrogen sulfide equals to my square root of the masses switched. So I know my mass of hydrogen sulfide is 34 grams and methyl salicylate is 152 grams. I know that I can cancel my grams. I can and I must. Okay, so perform this calculation, do the math, get the square root of your answer, don't forget, and you know that the rate is equal, the rate relationship is equal to 0.47 and I want to know methyl salicylate. Okay, so I isolate. That means that my ratio of hydrogen sulfide goes to the other side to multiply. So the ratio of methyl salicylate is 0.47 hydrogen sulfide. Now, at what velocity is this? The velocity is going to be equal to 0.47 times the given, that is 320 meters per second. This is equal to 150.4 meters over second. This is the velocity of methyl salicylate. This is one of my answers. Now, I'll do the same for benzaldehyde. I will use my Graham's equation. I say my rate of benzaldehyde against my rate of hydrogen sulfide equals to the square root of both of their masses but switched. So here we'll have my 34 grams and below I'm going to have benzaldehyde's mass, which is 106 grams. I cancel my grams units, and then I perform the calculations. 34 divided by 106, I get the square root of my answer, and I have this to be 0.57 rounded. So I know that the ratio of benzaldehyde is going to be 0.57 of hydrogen sulfide. So my velocity, this is my ratio. Now my velocity, I'm going to do it here. My velocity will be 0.57, the velocity of hydrogen sulfide, which is 320 meters over second. 0.57 times 320 is 182.4 meters over second. This is the velocity of benzaldehyde. Take a look. Well, the general analysis of this problem is the velocity increases if the mass is being reduced. Example, which one has the greatest velocity? The fastest one. Which one is the fastest? The one with the least of the masses, which is 34. So its velocity, it's given is 320 meters per second. Now, what happens with the others? I know the slowest of the gases must be the heaviest, which is methyl salicylate. And let's see, I have a velocity of 150. Between the three velocities, 320, 182, and 150, the least of the velocities is 150. So, as we assume in the first step, that gas, methyl salicylate, will be the slowest of the gases. Now, the one that will be in the middle, we said it was going to be benzaldehyde. And when we did the procedure here, sorry, yes, I mean 182 is a velocity between the least and the greatest. So guys, I hope you have understood the topic. See ya.